Hi there, we're going to review latitude longitude for your quiz and take a look at some latitude longitude types questions. First, let me just zip this up and make it a little bit larger. And let's see what the first question says. Base your answer to the following question on the diagram below and on your knowledge of Earth science. The diagram represents the lines of latitude and longitude on Earth. Points A through E represent locations on Earth. And from which location would an observer never be able to see Polaris? The answer here is going to be D. Can't see Polaris because it's below the equator. Also, E would be a possibility too, if it was a choice. What time is it in New York City when it's noon in Denver? So if it's noon in Denver, let me just use a text box right here. I'll put a 12 noon here and here, so 12, and noon would be 12 p.m. The next time zone over here would be to the east, and as you go to the east, your time will increase. So it's 1 p.m. here, and in the next time zone, time would increase as well, so it would be 2 p.m. And that matches up with one of the choices we have down below here, 2 p.m. Okay. The time exposure photograph shown below was taken by an observer in the northern hemisphere to record the apparent paths of stars. We see the stars all appear to be making streaks in the sky, except for this one right here, which is the answer to the question. The star that doesn't appear to be moving is Polaris. If an observer on Earth views Polaris on the horizon, the observer is located at. So your latitude is equal to the angle. And when you look at the horizon, you're neither looking up nor down. You're looking straight ahead. You're not tilting your head. So the angle that you're looking at is 0 degrees. You would be at the equator. For number 5, the diagram below shows an observer on Earth viewing the star Polaris, and they're looking up with an altitude of 52 degrees above the horizon. That's going to be equal to their latitude, which is going to be 52 degrees north. You would not use Polaris to find southern latitudes. The diagram below shows latitude measurements every 10 degrees and longitude measurements every 15 degrees. What's the latitude and longitude of point X? So one of the ways I can figure this out is the power of deduction. I see point X is in the northern hemisphere, so I know it can't be a southern hemisphere answer. I also see that it's in the western hemisphere, so I know it can't be eastern. So I do believe the answer is going to be letter B. Let me just double check, because it says the latitudes are by 10. So if I start here at the equator and go up, it'd be 10, 20, 30, 40, 50. That makes sense. And the longitude's by 15. So if I started here at 0, this would be 15, 30, 45. It does work out that letter B is the best choice. Okay. Number 7, the map below shows 3 locations labeled A, X, and B on the Earth's surface. Which table correctly indicates solar times at locations A and B when it's 12 at location X? So let me just make a little note here at location X. The time is 12 noon, which would be 12 p.m. All right, so location X, this time is 12 p.m. If I take a look at where location A is located 90 degrees to the west. Let's see, so the difference in angle would be a difference of 90 degrees. If I take 90 and divide it by 15, I see that the time difference is going to be a difference of 6 hours. And since A is to the west of X, it's going to be 6 hours less. So at X, it's 12. At 12 p.m., that would mean over here it would be 6 a.m. Okay, so I've got that. Now, what about B? B's over here, and it's at 45 degrees, so the difference here is 45 degrees. And if I take 45 and divide that by 15, I'm going to get a time difference of 3 hours. Now, this is to the east, so this is going to be an increase of 3 hours, which means if it's 12 p.m. at X, 3 hours later at B, it's going to be 3 p.m. So putting all that together, it looks like choice B is the best choice. It says A would be 6 a.m., B would be 3 p.m. All right, let's look at the next one over here, number 8. We see that this person is tilting their scope up 20 degrees above the horizon. So that's the angle of Polaris. Their latitude would be 20 degrees north. Let's look at question number 9. The map below shows a portion of Earth's system of latitude and longitudes in 5 surface locations, A, B, C, D, and X. And it says if it's solar noon at location X, at what location will solar noon be next? So let me make a little mark down here that it's solar noon here at X, and that means it's 12 p.m. Okay. Now, if it's 12 p.m. here, I'm going to figure out what time it is at different places and figure out who's going to have the next solar noon. So if I go in this direction right here, this comes down to about, it looks to me like about 95, which would be a 15-degree difference right here. And it's to the east. So 15 degrees is equal to 1 hour of time. And since it's to the east, it's an increase. So right here, this would be 1 p.m. And this indicates something about this location. This location's already had its solar noon. So obviously, if this has had its solar noon already, this has already had its solar noon too. So solar noon is going to happen to one of these 2 locations next. Now, letter B, if I take this down, is at 65. 65 compared to 80 is a difference of 15. So 15 degrees means that this is 1 hour behind, which means that right here, we're looking at 11 in the morning for this location, 11 a.m. And that means that they haven't had their solar noon yet. So letter B is our best choice for this. And this one over here would be 10 a.m. And by the way, this one over here would be 2 p.m. Okay, the diagram below shows an observer measuring on Earth measuring the altitude of Polaris. Their measurement should always be off the horizon, so 66.5 degrees north is the right answer. Number 11, as a ship crosses the prime meridian, an observer on the ship measures the altitude of Polaris at 60 degrees. What is the ship's location? So since they just crossed the prime meridian, their longitude is 0. And because they can even see Polaris, they must be in the northern latitudes. So they see Polaris at 60, it would be letter B, 60 degrees north and 0 degrees longitude. The angle of the star Polaris above the northern horizon can be used to determine an observer's latitude. And as a person travels due west across New York State, they're not going north or south, so their latitude isn't changing. So the altitude of Polaris will remain the same. Okay, so now we have the story about the shipwreck. In 1641, the crew of the ship Concepcion used the sun stars for navigation. The crew thought the ship was just north of Puerto Rico, but ocean currents had carried them off course. The ship hit a coral reef and sank off the coast of the Dominican Republic. The X on the map marks the location of the sunken ship. Interesting. And so in this diagram here, we can see the latitudes. It's in the northern hemisphere because they're getting greater this way. And it's in the western hemisphere because they're getting greater as we go to the left. Now, at which map location does Polaris appear to be highest in the sky? That would be where we have the highest latitude, Miami, Florida. What is the approximate latitude and longitude of the sunken ship? So the latitude, I would go over this direction, and it's coming in pretty close to around 21 degrees north. Maybe slightly under that. Drew a line with that, you'd be able to see that a little bit better. Okay, for longitude, longitude's going to go straight down like this, or straight up. And I can see about where those 2 numbers are. So I think of all the choices, first I know it's in the northern hemisphere, so it can't be C and D. And it looks to be about 20.5 degrees north, but we're in the western hemisphere. So we see the numbers are increasing away from the prime meridian, so it would have to be letter B. Since Denver's longitude is 105 degrees west and Utica's is 75, sunrise in Denver occurs. Now, because they're not on the same longitude, or different longitudes, they're going to have different times to them. And 105 minus 75 is a difference of of 30 degrees. So the difference equals 30 degrees. And if I take that 30-degree difference and divide it by 15 degrees per hour, I see that I have a 2-hour difference. Okay, so I know that choices A and B are possible, but which one is which? Well, Utica is more east than Denver is. Denver's further to the west. So the time in Denver is going to be behind. So let's say that sunrise happens in Utica at 7 in the morning. When it's 7 in the morning, it's 5 in the morning in Denver. Denver will have to wait 2 more hours before sunrise occurs. So sunrise in Denver occurs 2 hours later after it does in Utica. A person knows the solar time and the prime meridian local time. What determination can they make? They can figure out their longitude, letter C. Okay, and last questions here. Which two observers would be experiencing the same apparent solar time? The same apparent solar time is going to happen when you're on the same longitude. So the right answer here would be B and E, though if choice A and D were given, that would also be correct. And what is the altitude of Polaris above the northern horizon for observer A? Well, observer A is located at latitude of 10 degrees north, and so they're going to see Polaris at 10. All right, those were some great review questions. Hopefully help you with your quiz. Good luck, and thanks for listening.